Hello everyone. We have different elements around us. We know about them. These elements can be found either in a free state or in a combined state in the Earth's crust, termed as metals and nonmetals. So, today, let us discuss something more related to this in our lesson Metals and Nonmetals. The first subtopic is metals. A metal is a material that is typically hard, opaque, shiny, and has good electrical and thermal conductivity. Metals are generally malleable. They can be hammered or pressed permanently out of shape without breaking or cracking, as well as fusible, able to be fused or melted, and ductile, able to be drawn out into a thin wire. Nonmetals. A nonmetal is a material that is dull, softer, and mostly lacks metallic attributes. Physically, nonmetals tend to be highly volatile, have low elasticity, and are good insulators of heat and electricity. 17 elements are generally classified as nonmetals. Most are gases, example hydrogen, helium, nitrogen, oxygen, fluorine, neon, chlorine, argon, krypton, xenon, and radon. One is liquid, that is bromine, and few are solids, those are carbon, phosphorus, sulfur, selenium, and iodine. Now let us see the physical properties of metals. The first property is hard and strong. Metals are generally hard, strong solids. They are strong enough to bear heavy loads, that is, they have a high tensile strength. We generally look for a metal when we need a strong material. This is because metals are in general hard and strong. Some examples of metals are magnesium, aluminium, iron, etc. There are few exceptions. Sodium and potassium are soft solids which can be cut with a knife, and mercury is a liquid under ordinary conditions. Whereas in nonmetals, most of them are gases. Only few are solids which are not very hard in nature. The second one is lustrous. They have a luster known as metallic luster. For example, aluminium, iron, zinc, copper, silver, and gold are all lustrous. Such metals can be polished too. The next property is sonorous. Metals are sonorous. When struck, they produce a sound called as a metallic sound or a metallic clink. Malleability. Metals are malleable. In other words, they can be beaten or rolled into sheets. Aluminium, iron, copper, or silver can be beaten or rolled into thin sheets. Common examples are the silver foil used to decorate sweets and aluminium foil used to pack foodstuff. Ductility. Metals are ductile, that is, they are flexible and can be drawn into wires. For example, iron, aluminium, copper, silver, and gold can be easily drawn into wires. Metals are good conductors of heat, that is, they allow heat to pass through them easily. Due to this property, we use metal utensils in kitchens. Heat supplied at one place of the utensil is conducted all over it. You cannot use a frying pan made up of cardboard because it is a bad conductor of heat. When placed over fire, cardboard does not distribute the heat all over the pan. Instead, it starts burning due to the localized heat. Metals are good conductors of electricity. That is, they allow an electric current to pass through them easily. This is why electricity is transmitted from one point to another through metal wires, like those of copper or aluminium. Silver is the best conductor of electricity. The next best is copper and then aluminium. You cannot use nylon or jute ropes for electrical transmission, as nylon and jute are bad conductors of electricity. Physical properties of nonmetals. In contrast to metals, nonmetals are not known for strength. They are usually lusterless, that is dull, except graphite and iodine. The second property is brittle. Third, bad conductors of heat. Fourth, bad conductors of electricity except graphite. And they are non-sonorous, that is, they do not produce a metallic clink. Of the 24 nonmetals known today, 12 are solids, that is carbon, silicon, phosphorus, sulfur. One is liquid, that is bromine, and 11 are gases, example hydrogen, nitrogen, oxygen, fluorine, chlorine, helium, neon, argon under ordinary conditions. This is a table showing properties between metals and nonmetals. Chemical properties of metals. Reaction of metals with oxygen. Metals form their oxides when react with oxygen. Metal oxides are basic in nature. Example, reaction of iron metal with oxygen gives us the following reaction. When iron reacts with moist air, it forms rust. Rust is iron oxide. Articles made of iron such as grills, fencing, etc. are get rusted because of reaction with moist air. Rust is reddish brown in color and is iron oxide. Iron oxide is basic in nature. It turns red litmus paper blue. Reaction of magnesium metal with oxygen gives us the following reaction. When magnesium is burnt in air, it forms magnesium oxide. Burning in air means reaction with oxygen. Magnesium oxide forms magnesium hydroxide with water. Solution of magnesium oxide turns red litmus paper blue. This means magnesium oxide is basic in nature. Chemical properties of metals. Reaction of metals with water. Generally, metals form respective hydroxide when they react with water. First one, reaction of sodium metal with water. Sodium metal vigorously reacts with water and forms sodium hydroxide along with lot of heat. Reaction of potassium with water gives us the following reaction. Potassium metal vigorously reacts with water and forms potassium hydroxide along with a lot of heat. Reaction of metals with dilute acid. Metals give hydrogen gas when they react with dilute acid. Reaction of zinc with dilute acid gives us the following reaction. Zinc gives hydrogen gas along with zinc chloride when it reacts with hydrochloric acid. Similarly, zinc gives hydrogen gas along with zinc sulfate when it reacts with sulfuric acid. This method is used to produce hydrogen gas in laboratory. Reaction of aluminium with dilute acid. It gives us the following reaction. Aluminium gives hydrogen gas along with aluminium chloride when it reacts with dilute hydrochloric acid. Chemical properties of nonmetals. Reaction of nonmetals with oxygen. Nonmetals forms their oxides when react with oxygen. Thus, nonmetal forms their oxide when reacts with oxygen. First one, reaction of sulfur with oxygen. When sulfur is burnt in air, it forms sulfur dioxide. Solution of sulfur dioxide turns blue litmus paper red. Sulfur dioxide forms sulfurous acid when dissolved in water. Thus, sulfur dioxide is basic in nature. Reaction of carbon with oxygen. When carbon is burnt in air, it forms carbon dioxide. We can observe that when coal is burnt, it forms smoke, which contains carbon dioxide. Carbon dioxide is basic in nature. The solution of carbon dioxide in water turns blue litmus paper red. Chemical properties of nonmetals. Reaction of nonmetals with water. Nonmetals generally do not react with water. Rather, some nonmetals which react with air vigorously are stored in water. Reaction of nonmetals with dilute acid. Generally, nonmetals do not react with dilute acid. Now let us see the uses of metals. Iron is used in making machinery, buildings, car, motorcycle, ships, bridge, etc. Copper is used in making electric wires, statue, etc. Aluminium is used in making kitchen utensils, electric wire, etc. Gold is used in making ornaments. Also, silver is used in making ornaments. Uses of nonmetals. The number of nonmetals is very less in comparison to metals, but nonmetals are more useful for us. So far, only 22 nonmetals are discovered. We breathe oxygen, which is a nonmetal. Without oxygen, no one can live. Sodium chloride cannot be formed without chlorine, which we use to enhance the taste of food. Without using common salt, food is tasteless. Nitrogen is used in making fertilizers. Coal, which is carbon, is used as fuel. So, this was all about our lesson metals and non-metals. Learning about them is very important as metals and non-metals are used in our everyday life, and knowing about their properties and using it wisely is very important. Thank you, students.